Welcome back to the last of the Atoms, Elements and Compounds series in the IGCSE 0620 Chemistry area learning outcomes. So we're looking at the last bit here, 2.6, giant covalent structures, learning outcomes 1 to 2. Here they are. Core outcomes: describe the giant covalent structures of graphite and diamond. Number 2, relate the structures and bondings of graphite and diamond to their uses, limited to graphite as a lubricant and as an electrode, and diamond in cutting tools. I'll pose a question as I always do. If you can answer these, great. If not, by the end of this short lesson, you should be able to do so. Can you describe the giant covalent structures of graphite and diamond? I wonder if you can. Maybe you can, maybe you can't, but let's go to the next question I pose. Can you relate in terms of the structure and bonding of graphite and diamond and name some of their common everyday uses if you don't already know? Now, the second part of the information. Okay, giant covalent compounds, structures, learning outcome 1 and 2. Graphite is a giant covalent structure composed of carbon layers, atoms in hexagonal layers. Within each layer, the carbons are bonded to 3 name ring carbon atoms. Therefore, they make very strong covalent bonds, forming a two-dimensional network of interconnected layers of hexagons. Okay, these are stacked on one another, all right, not connected with strong forces in between. So they're the weak van der Waals force. Here's what it really looks like in real life if you ever dig it up in the earth, as it were. And here's what we think theoretically what it looks like. And as you can tell here, we've got the, just do it in red, you've got the hexagonal layers here, and then you've got the weak van der Waals forces here. And you can see they're stacked up on one another. There's 1 stack, there's 2 stack, there's 3 stack. So there's your hexagonal layers here. Okay, next bit of information, we're looking at diamond. Diamond is a girl's best friend. Maybe not, maybe so. Diamond is also a giant covalent network structure made entirely of carbon atoms, so we call it an element. Each carbon atom is covalently bonded to 4 neighboring carbon atoms, forming a 3-dimensional network. We know it as a tetrahedral structure. So it's incredibly strong. It's a continuous lattice structure, and you can see it's surrounded by this tetrahedral structure here. So here's what it looks like here, and there's your tetrahedral structure here. Is when it's all cut up nicely using a jeweler to cut up into different facets, and here's diamond. Okay, here we go. The next one, graphite and its uses. Graphite, due to its layered structure, possess unique properties and specific applications. So it's very good for a lubricant. And that's because it's got weak forces between hexagonal layers and they're able to slide over one another. So you can use them as lubricating oils between 2 surfaces and also between machinery parts, and obviously the classic use of pencil on paper. Graphite, in terms of another use, it's excellent conductor of electricity due to its delocalized electrons. Okay, so they can move freely between the carbon covalent structure, and we can use them for electrodes, utilize also batteries. So these are your typical graphite electrodes. You can use in electrochemistry and voltaic cells and somewhat. Is the use of diamond, okay, because it's strong covalent bonds, rigid structure and repeating pattern of tetrahedral. So exceptional hardness and wear and tear used in cutting tools. You can see here, and they can nicely cut through metals during the cut process without losing their sharpness. The hardest known substance on the Mohs hardness scale, having a rating of 10.